NEC 430.82 requires that disconnecting means for motors be located within sight of the motor. It does not specifically address the issue of off positions on hand-off auto switches. NEC 430.92 states that where a motor is not within sight from its disconnecting means, the controller shall be capable of being locked in the off position. This implies that the off position on a hand-off auto switch should be effective in preventing the motor from being energized. The utility company's assertion that NEC 430.82 does not require an actual off position on hand-off auto switches is not fully supported by the NEC. While NEC 430.82 does not specifically address this issue, NEC 430.92 implies that an off position should be effective in preventing the motor from being energized. The potential hazard identified is a valid concern. If the hand-off auto switch does not have a true off position, there is a risk that someone could inadvertently turn the switch to off while the motor is still capable of running due to other control inputs such as limit switches or pressure switches, creating a safety hazard. It is recommended that the utility company add an additional contact block to the hand-off auto switch or install a hand/auto switch in the bucket door to correct this potential hazard. This would ensure that the off position on the hand-off auto switch is truly effective in preventing the motor from being energized, regardless of the status of other control devices. Consider a scenario where a maintenance worker needs to perform work on a pump controlled by an MCC bucket. They turn the hand-off auto switch to the off position, assuming that the pump is now de-energized and safe to work on. However, if a limit switch or pressure switch is closed, a pump could still start unexpectedly, even with the hand-off auto switch in the off position. This could result in serious injury or even death. The addition of a contact block or a hand/auto switch would ensure that the off position on the hand-off auto switch truly isolates the motor from its power source, regardless of the status of other control devices. This would provide a much safer working environment for maintenance personnel. This is an important safety consideration for any motor control system, especially those used in critical applications such as utility pumps. By ensuring that the off position on the hand-off auto switch is truly effective, utility companies can help to prevent accidents and injuries. The proper design and implementation of motor control systems are essential for ensuring the safety of workers and the reliability of equipment. The NEC provides guidance on many aspects of motor control system design, including disconnecting means, overload protection, and control circuit wiring. It is important for electrical engineers and technicians to be familiar with the NEC requirements for motor control systems. One important aspect of motor control system design is the selection of appropriate disconnecting means. The disconnecting means must be capable of safely disconnecting the motor from its power source in the event of a fault or emergency. The disconnecting means must also be located within sight of the motor, unless it can be locked in the off position. Overload protection is another important aspect of motor control system design. Overload protection devices are designed to protect the motor from damage caused by excessive current draw. Overload protection devices typically consist of thermal overload relays or circuit breakers. Control circuit wiring is also an important consideration in motor control system design. Control circuits are used to start, stop, and control the motor. Control circuits must be properly wired and protected to prevent short circuits and other electrical hazards. The NEC provides detailed requirements for control circuit wiring, including wire size, insulation type, and overcurrent protection. In addition to the NEC requirements, there are also a number of industry standards and best practices that should be followed when designing and installing motor control systems. These standards and best practices can help to ensure the safety and reliability of the motor control system. When designing and installing motor control systems, it is important to consider the specific application and the environment in which the motor will be used. For example, motors used in hazardous locations require special protection to prevent explosions. Motors used in corrosive environments require special materials and coatings to prevent corrosion. By carefully considering the application and the environment, it is possible to design and install a motor control system that is safe, reliable, and efficient. In conclusion, the safety of the hand-off auto switch's off position is a crucial aspect of motor control center design. While NEC 430.82 focuses on the location of disconnecting means, NEC 430.92 provides a basis for ensuring a truly effective off position, especially when the motor isn't within sight of the disconnect. Addressing this potential hazard through additional contact blocks or a hand/auto switch is a proactive step towards mitigating risks and enhancing worker safety. The design and implementation of motor control systems should always prioritize safety and compliance with relevant codes and standards. The potential for unexpected motor operation, even with the hand-off auto switch in the off position, presents a significant safety hazard that must be addressed to protect personnel and prevent accidents. The addition of a contact block or a hand/auto switch would provide a redundant safety measure, ensuring that the motor is truly de-energized when the hand-off auto switch is in the off position. This is particularly important in situations where other control devices, such as limit switches or pressure switches, could override the hand-off auto switch and cause the motor to start unexpectedly. In addition to the safety benefits, implementing this recommendation could also improve the overall reliability of the motor control system. By ensuring that the motor is truly de-energized when the hand-off auto switch is in the off position, the risk of damage to the motor and other equipment is reduced. This can lead to lower maintenance costs and increased uptime. The decision to implement this recommendation should be based on a thorough risk assessment, taking into account the specific application and the environment in which the motor will be used. However, in most cases, the benefits of implementing this recommendation will outweigh the costs. By prioritizing safety and investing in a robust motor control system design, utility companies can protect their workers and ensure the reliable operation of their equipment. The implications of a faulty or ineffective off position can extend beyond immediate physical harm. Consider the potential for damage to equipment caused by unexpected startup, the disruption to processes reliant on the pump's operation, and the potential liability for the utility company in the event of an accident. The small investment in a more robust hand-off auto switch configuration can significantly reduce these risks. From a broader perspective, this situation highlights the importance of proactive safety measures in all aspects of electrical system design and operation. It is crucial to identify potential hazards and implement solutions before accidents occur. This requires a commitment to safety from all levels of the organization, from management to field personnel. Regular training, thorough risk assessments, and adherence to industry best practices are essential for creating a safe working environment. In the context of motor control centers, it's important to remember that these systems are often complex and involve a variety of components and control schemes. It's essential to have qualified personnel design, install, and maintain these systems to ensure their safe and reliable operation. This includes understanding the functions of each component, the interaction between different components, and the potential hazards associated with the system. Furthermore, the documentation for the motor control system should be comprehensive and readily available to maintenance personnel. This documentation should include wiring diagrams, component specifications, and operating procedures. Proper documentation can help to troubleshoot problems quickly and efficiently, and can also prevent accidents caused by misunderstanding the system. Ultimately, the goal is to create a motor control system that is not only functional but also safe and reliable. This requires a combination of good design, proper installation, regular maintenance, and a commitment to safety from all involved. In addition to the specific issue of the hand-off auto switch, there are a number of other safety considerations that should be taken into account when designing and installing motor control systems. These include ensuring proper grounding, providing adequate overcurrent protection, and protecting against arc flash hazards. Grounding is essential for preventing electrical shock hazards. A properly grounded system provides a low impedance path for fault current to flow, which helps to trip overcurrent protection devices and to energize the circuit. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the system from damage caused by excessive current flow. These devices should be properly sized and installed to ensure that they will trip quickly and reliably in the event of a fault. Arc flash is a dangerous electrical phenomenon that can occur when a short circuit creates a high-energy arc. Arc flash can cause serious burns, blindness, and even death. Motor control systems should be designed to minimize the risk of arc flash hazards. This can be achieved through a variety of measures, such as using arc-resistant equipment, providing adequate clearance around energized equipment, and implementing safe work practices. By addressing these and other safety considerations, it is possible to create a motor control system that is safe for workers and reliable for the operation. The principles discussed extend beyond utility pumps and are applicable to a wide range of motor-driven equipment in various industries. Ensuring a positive and reliable off position on hand-off auto switches is a fundamental safety practice that should be implemented whenever possible.